Find the open intervals on which the function is increasing and those on which it is decreasing. The function is f of x equal to x to the 1/3 times x squared minus 16. We can simplify the process of finding the first derivative by multiplying through by x to the 1/3. We would wind up with x to the 7/3 minus 16x to the 1/3. The first derivative then would just be the derivative of each term, which would be 7/3 x to the 4/3 minus 16/3 x to the negative 2/3. We will need to set this equal to 0, so we should probably do some algebra on this to make that process a little easier. The first term we could write as 7x to the 4/3 over 3. The second term we could write as 16 over 3x to the positive 2/3. In order to combine these terms, we would need a common denominator. We could do that by multiplying the top and bottom of the first term by x to the 2/3. This will give us the first derivative, f prime x, equal to 7x squared minus 16 over 3x to the 2/3. In order to find the local extrema, we should find where this first derivative is equal to 0. This fraction can only be equal to 0 if the numerator is equal to 0. So we'll set 7x squared minus 16 equal to 0, add 16 to both sides, and we would wind up with 7x squared equals 16. Divide both sides by 7, and we'll have x squared equal to 16 over 7. Find the square root of both sides, and then rationalize the denominator, and we would wind up with x equals plus or minus 4 times the square root of 7 over 7. Now let's look at a number line. We'll put 0 here in the center, and then out here to the left, we'll have a point where x is minus 4 times the square root of 7 over 7, and then a point to the right where the x-coordinate is 4 times the square root of 7 over 7. Now, in order to determine where the function is increasing and decreasing, we would need to find where the first derivative is positive and where it's negative. We are using these values of x because they are the points where the first derivative is equal to 0. 4 times the square root of 7 over 7 is approximately 1.5 if we round to one decimal place. So we know that negative 2 would be to the left. So let's find the value of the first derivative when x is negative 2. F prime of negative 2 will be 7 times negative 2 squared minus 16 divided by 3 times negative 2 to the 2/3. All we really care about is whether this is positive or negative. In the numerator, we would have 28 minus 16, which would be a positive value. And in the bottom, we would have 3 times the cubed root of negative 2 squared, so it would become positive. So this quantity would be positive. In between these critical points, we could use 1 as a convenient value for x to find the value of the first derivative. F prime of 1 would be 7 times 1 squared minus 16 divided by 3 times 1 raised to the 2/3. The numerator here would be negative 7 minus 16. The denominator would be positive. So here, in between these two critical points, the first derivative would be negative. To the right of the critical point 4 times the square root of 7 over 7, we might use 2. Finding the first derivative evaluated when x is 2, we would have f prime 2 equal to 7 times 2 squared minus 16 divided by 3 times 2 raised to the 2/3. Again, this is going to be positive. We looked at where the first derivative is equal to 0 by setting the numerator equal to 0. But if we set the denominator equal to 0 and find where the first derivative is undefined, that would happen at x equal to 0. This would indicate to us that the slope of the tangent line at x equals 0 is undefined, so therefore vertical. So we may want to continue and check what the first derivative is doing when x is -1. So we'll find the first derivative evaluated at x equal to -1, and we'll find that since x is squared in the numerator and the denominator, that derivative would have the same value as when x is equal to +1. So it remains negative. So now the question is, where is this function increasing and where is it decreasing? We would say that it is increasing on the interval -infinity to -4√7/7 union 4 times the square root of 7/7 to infinity. It is decreasing on the intervals -4 times the square root of 7/7 to 0 union 0 to 4 times the square root of 7/7. Looking at the graph of the function, we can see the shape of the graph and these intervals of increase and decrease that we found using the first derivative. The graph is increasing until we get to this point, and then decreasing with a vertical tangent line at 0, and then decreasing again until we get to this point, which is 4 times the square root of 7/7, and then continues to increase again. The B part of this problem asks us to find the function's local extreme values. So in other words, we're to find the coordinates of these points. So we need to find f of -4 times the square root of 7/7. This will be -4 times the square root of 7/7 to the 1/3 power times -4 times the square root of 7/7 squared minus 16. Using our exponent properties, we would have -4 raised to the 1/3 power times the square root of 7 raised to the 1/3 power. We could write the square root of 7 as 7 to the 1/2, then raised to the 1/3 power. And then on the bottom, we would also have 7 to the 1/3 power. This would be times, now squaring everything, we would have -4 squared is 16. The square root of 7 squared would be 7, and 7 squared would be 49, minus 16. Simplifying this, we would have -4 to the 1/3 power times 7 to the 1/6 divided by 7 to the 1/3 times 16/7 minus 16. But in order to combine these, we will need a common denominator. 16 times 7 is 112, so we would have 112/7. This will then give us -4 to the 1/3 power. We are dividing with like bases, 7, so we would subtract exponents. The larger is on the bottom. 1/3 minus 1/6 is 1/6, so we have 7 to the 1/6 on the bottom. Then we have -96/7. Now, multiplying these fractions together, we have on the bottom 7 to the 1/6 times 7. This is 7 to the understood 1 power, and when we multiply with like bases, we add exponents. So 1/6 plus 1, or in other words 6/6, is 7/6. So we have a negative times a negative, so that's going to be positive. So we'll have 96 times 4 to the 1/3 power over 7 to the 7/6 power. So that would be the y-coordinate for this dot. The y-coordinate for the minimum value would just be the opposite of this. So the y-coordinate for our relative minimum value would be -96 times 4 to the 1/3 divided by 7 to the 7/6. So these are our relative minimum value and our relative maximum value. The answer to the question where they occur would be given by the x value of these points. That would be the critical values that we found, negative 4 times the square root of 7 over 7, and positive 4 times the square root of 7 over 7.